We are talking about slope today, so I hope that you watched the riveting, exciting Slope Dude video, which can be found anytime on YouTube if you would like to rewatch it. So, Slope Dude told you that lines can have different slopes. They can have a positive slope, a negative slope, zero slope, or no slope, which is undefined, is another way to say that. So what is slope? Slope has to only applies to linear functions. So we're going to spend the rest of this semester talking about linear functions. You can see the word line in there. So linear functions has to do with lines. That means they graph as a straight line. So slope is the rate of change of that line, and what rate at which it's increasing positive or decreasing negative. You need to know that rate of change means slope because sometimes a test question will ask you for the rate of change. You need to know what they're talking about. Um, the Greek symbol delta is often used to represent change. So we might say delta y over delta x. Whoops, I wrote an A instead of a delta. Delta y over delta x, that means change in y over change in x. It's the rise over the run. The rise over the run. So y goes up and down. So as something rises, the y changes, and then the run is the x change. So you need to know that it's rate of change, delta y over delta x, change in y over change in x, rise over run. It also, sometimes the m, which we'll learn more about tomorrow, means slope. And I don't know why I wrote these so little because that's all we're writing there. All right, let's look at a graph. Let's say that, now I know this is very hard to see because it's tiny. Maybe I can zoom in. So let's say we have the graph of a line. I'm going to put a point over here at 1, 2, 3, 4, 5, 1. Then I'm going to put a point at negative 3, negative 2. Let's connect the dots. This is a positive slope. So the way we find slope from a graph is we count our rise over run. So let's count from one point to the next. To get from here, you can kind of draw a little triangle if you want to. To get from here to here, I go up, I rise, 1, 2, 3, and I go over, I run, 1, 2, 3, 4, 5, 6, 7, 8. So my slope of this line, now it's positive because it's puff, puff, positive, like Slope Dude said. My slope is 3 over 8, rise over run. Let's look at a negative one. Let's put a dot at, if I can read my own writing, let's put a dot at like negative 1, 1, and let's put a dot at like 8, 0. That's actually a 6. So 6, 0, negative 1, 1. This is going to have a negative slope because I'm going, well, it's nice, negative, and I'm going to go down 1 to get to this point, and I'm going to go over 7. So it's a negative 1 over 7, rise over run. Actually, this time it wasn't rise, it was fall, right? I could have gone to it this way, or I could have gone to it this way. Either way, it's a negative, nice negative. So let's go over here to 2 points. Let's say that I don't have the graph, that I just have 2 points, and I want to find the slope. So I have the point negative 2, 1, and the point 6, 8. There is a formula, the slope formula, that we will use. We will plug into this formula. It'll work every time. I could have done it with my graph. I could have found 2 points on my line and plugged them into this formula. Or I could have just counted. I thought it was easier to count. So my slope formula is y2 minus y1 over x2 minus x1. We know that this is xy and this is xy. Well, let's call this point 1 and point 2. I don't really care which one you call which. So if I needed to, I could say x1, y1, x2, y2. So I take the y2 and I subtract the y1. I'm plugging into a formula, guys. Then I take the x2 and I subtract the x1. Now I've got minus and negative. We need to be careful with that. Now I'm going to either type this into my calculator. Sorry guys, I'm trying to find my pen. I can type it into my calculator or I can just do the math in my head, but 8 minus 1 is 7. And then 6 minus a negative 2, that becomes plus. So what is my slope? It is 7 over 8. Now, could I have called this x1 and this x2 and gotten the same slope? Why, yes, I could. I could have started here and gone 1 minus 8 over negative 2 minus 6. I would have gotten negative 7 over negative 8, which reduces to positive 7/8. It would have given me the exact same answer. Let's try another one. Let's try the 0.19 and the 0.1 negative 7. Now, if I called this x1, y1, x2, y2, I would go negative 7 minus 9 over 1 minus 1. I would get negative 16 over 0. Guys, is it possible to divide by 0? Is it legal to have a 0 in the denominator? No, never. We can't do it. That means this one is a vertical line with an undefined slope. Here's your vertical line, undefined. It has no slope because you can't divide by 0. Now let's look at our table. There's two different ways we can do our table. So we can either pick any 2 points from the table and use this formula. That will always work. It doesn't matter which 2 points. You can always take any 2 points and use that, or you can see what the rate of change is. Remember I said change in y over change in x. So from 1 to 4 is adding 3, adding 3, adding 6, adding 3, adding 1, 1, 2, 1. If you do the change in y over change in x, every time you're going to get 3 over 1. This time we get 6 over 2, but look, that reduces to 3 over 1. So the slope is 3. But you don't have to do this. You can always pick any 2 points from the table and use this formula. So that's an introduction to slope and the different ways you will see it.